Now you can come to the sharing. Actually, you stop, and when your lecture will start, that time you will start sharing. Okay.
Sure. Sure. So I am able to see, so meet with everyone virtually over here. I wish, we could meet in person also, but, hopefully on different occasions, we would be able to meet again.
No, definitely. And we will be very happy to have you, and we'll have it, your physical presence here on a different occasion. Definitely.
Right, sir.
नमस्कार.
So many people have registered.
Mm-hmm.
Close to 40 fellows have registered.
Okay.
And
but so far, whether all of us included, it is only 10. Yeah. So maybe, let us wait for a minute or two. So
we'll start this way.
Yeah.
First of all, I will like to extend a very hearty welcome to all the participants present in virtual mode to this 70th distinguished lecture being organized by INAE Bhubaneswar chapter, SOA University, IIT Bhubaneswar, NISER Bhubaneswar, IMMT Bhubaneswar, ICT IOC Campus Bhubaneswar, and IEEE Bhubaneswar section. It is actually very fulfilling thing for all of us that we have been able to organize 70 such lectures over last little over 2 years. And today we are very, very happy to have amongst us Professor Sudeep Misra, who is INA Chair Professor, Department of Computer Science and Engineering, Indian Institute of Technology, Kharagpur, my alma mater. And so far as actually his title of the talk is concerned, all things connected, the age of intelligent networks. Today we live in smart and intelligent world in which everything is connected. The transformation from traditional network to ubiquitous connectivity has been enabled through the use of Internet of Things coupled with AI. Everyday objects equipped with sensors, actuators, embedded processor, and seamless communicate to each and other through layered architecture consisting of perception, edge, and cloud components. This enables the realization of a wide array of applications from smart agriculture, healthcare, education, campus management to defense and warfare. These applications have enormous economic and social benefits with the potential to transform lives across spectrum. His talk emphasizes on the widespread use of IoT and its amalgamation with ML and AI for developing impactful real-world applications solutions for persistent issues that exist, such as crop health monitoring using UAVs, predictive industrial monitoring, and physiological monitoring through body wearables. He will also discuss several products and solutions that have been designed at his Swan laboratory in IIT Kharagpur, as well as he will discuss emerging business opportunities driven by the convergence of AI and IoT towards future intelligent networks characterized by autonomous self-learning nodes and network components. His talk lays the foundational technologies and concepts required for achieving hyper-intelligence and connectedness, including the ethics and morals of using widespread AI. Professor Sudip Misra is the INA Chair Professor in Department of Computer Science and Engineering at the Indian Institute of Technology, Kharagpur. He received his PhD degree in Computer Science from Carleton University, Ottawa, Canada. His current research interest includes wireless sensor networks and Internet of Things. Over his illustrious career, Professor Misra has published over 550 scholarly research papers in 12 books. He has won a dozen research paper awards in different conferences and IEEE journals. Formerly, he was the INA Abdul Kalam Technology Innovation National Fellow. He was awarded the IEEE Communication Society Asia Pacific Outstanding Your Researcher Award at IEEE GlobeCon in 2012 in California, USA. He was the recipient of several academic awards and fellowships such as Faculty Excellence Award of IIT Kharagpur, Young Scientist Award of National Academy of Sciences, India, Young System Scientist Award of System Society of India, Young Engineers Award of Institution of Engineers, Canada, Canadian Government Council Academic Gold Medal at Carleton University, the University Outstanding Graduate Student Award at the doctoral level at Carleton University, the National Academy of Sciences, India, among many others. Professor Misra has served in editorial board of high impact journals and transactions of IEEE and SCM. He is fellow of the SCM, IEEE, and National Academy of Sciences, India, Indian National Academy of Engineering, and the Institution of Engineering and Technology, IIT UK, British Computer Society, UK, Royal Society of Public Health, UK, and the Institution of Electronics and Telecommunication Engineering, IET, India. Professor Misra was the distinguished lecturer at the IEEE Communication Society. He has been serving on the executive committee of IEEE Kharagpur section from 2008 in different capacity and was the chair of the IEEE Kharagpur section. He is also the director and co-founder of the IoT startup Sensor Drops Networks Private Limited. With this brief introduction of his topic of today and that of Professor Sudip Misra, I will now request him to make his presentation. Professor Sudip Misra, please.
So at the outset, thank you so much, INA Bhubaneswar chapter and all the other associated host institutions, who chose me to deliver the lecture today in this popular INA Distinguished Lecture Series. My special thanks and regards to esteemed, respected Professor Damodar Acharya for taking the initiative to invite me and give me the opportunity to interact with all of you who are present over here today. At the outset, I would also like to thank all of you who have taken your time in this weekend evening to be present over here for this virtual interaction. So with this, let me start my presentation. And I am assuming that many of you who have joined over here, you may not have the technical background in the areas of network, computer networks, Internet of Things, or AI and machine learning, which in my opinion is not required, because in this talk I have tried to pitch myself at a level which will enable anyone with a general understanding of different technologies that are present today to be able to understand at a level, at a high level, whatever I am going to present. So as you have heard already, the title of the talk is All Things Connected, the Age of Intelligent Networks. I would like to mention that I am leading since several years now at IIT Kharagpur, the SWAN lab, the Smart Wireless Applications and Networking lab. And due to the hard work of many of my former and present students, research students, we have been able to innovate on different fronts in different technological areas, allied technological areas, because of which, so there are a lot of innovations that have come out, and so a lot of not only research papers and all of these things in high quality journals and conferences, but also there are high TRL level products or prototypes, advanced prototypes that have also resulted from our works. So once again, the credit basically goes to all my students who have been associated with me since the last several years. So with that backdrop, let me start. I see that many of you who are present over here, you come with a lot of experience of decades. So particularly you would be able to appreciate the transition that we are going through in our society. So many of us, we have been visiting physical libraries, like for instance, during my undergrad, postgrad, or even during the PhD also, the way we used to do literature search, right? So, how we used to use the libraries those days is different from how the libraries are used at present by our research scholars. And that is pretty much understandable. I do not really need to elaborate on that. Not only research scholars, basically for the teachers also. So for instance, I myself, I cannot remember how many times I have gone physically to the library of IIT Kharagpur in the last few years to actually look for a book or look for a journal which can be used for the pedagogical purposes in my classrooms for the students. So things are changing. We used to write a lot of paper, letters, postal letters, etc., using pen, paper, etc. So those are gone now. Nowadays, we hardly write anything by hand. So we are basically, everything is typed, everything is instantly sent. Messaging platforms have changed. So there are so many instant messaging platforms also that have come up. So everybody, if you look at, are undergoing a technological transformation. So, when we were kids, at that time, telegrams were quite common, where telephony was common. Nowadays, hardly anybody uses, except the offices, basically hardly anybody uses wired telephones also, right? So things are changing, and what we find is that everybody is connected. Doesn't matter which part of the world we are in, we can be instantly connected, right? And that's the beauty of what we are, the world that we are living in. So are we living in some sort of a magical world? So everybody is connected, all things are gradually getting connected. So special thanks basically are to technologies such as smartphones, and the different current generation of cellular technologies like 4G, 5G, and even beyond, right? Because of which all of these things that we are talking about are possible. And there are many other associated technologies also that eventually at different points of my lecture, I'm going to talk about. So nowadays we are talking about instant connectivity, real-time connectivity, video calling, live sessions, and including this example of what we are doing now, right? All of us, we have joined this platform today to listen to each other from different parts of our country, right? And we are able to interact, we are able to talk, we are able to listen to each other, right? And how is it facilitated? It is facilitated by the different video conferencing platforms like Microsoft Teams and others. So I think we are able to appreciate the transformation that we are all going through. Anywhere in the world you go, you find that there is a change. Everybody is connected, things are getting connected, connectivity is increasing, and it is drastically, exponentially increasing. We are able to get data from anywhere in the world. So for instance, all these things are happening where a farmer who has some land in West Bengal can travel to any part of the world and still be able to monitor their farmland even if they are traveling. So I'm not talking about any kind of science fiction anymore. Even 10 years back, when I used to say these sort of things, so everything sounded very, sci-fi type. But now these things are a reality. We are not talking about anything really, really innovative in the current day. I'll just give you two examples which will help me to keep my point and put it across. Some of you, like me, who have joined in this platform, let us take the use case, let us take the scenario of young parents like me who have children going to school, right? So what happens is that many of us, including me, we have experienced that when we drop our child in the school, after that we remain worried. We are worried for several reasons. We are worried about whether our kid is paying attention in the classroom, in the school. We are worried whether they are hurting themselves while playing in the school playground. We are worried about several different other things when they are away from us. We are coming to our offices, but our mind is still with our kids who are dropped in the school. So so sometimes what happens due to unfortunate events, for instance, a child while playing in the school, hurts himself or herself, and sometimes it can be, they can badly hurt themselves. So typically what happens in such a scenario is that the school authorities are informed by the other, classmates and so on. And from the office or from the principal's office, a call goes to the nearby ambulance, the hospital. The hospital sends the ambulance. The ambulance comes through a busy road, right? Typically in cities like Bhubaneswar, Kolkata, etc., roads are often congested. So the ambulances come, they pick up the child and go through the congested roads again to the nearby hospital. And in the process, basically, the parents are also informed. The parents frantically, they are going to rush to the hospital to know the welfare of their children. So you see that what is happening is that everything happens manually. So if somebody, a human operator, has to call and do the things and get things connected and make things happen. But think about a world where everything autonomously, without any human intervention, are going to happen. So the use case that I talked about, can it be fulfilled automatically and autonomously without any human intervention whenever some event occurs, right? So all of these different things that I narrated just now to illustrate the use case, can these be fulfilled one after the other and also the different branching conditions that I mentioned are also going to be fulfilled depending on the conditions in place. It's possible. Let me tell you that it's possible. It is happening in my lab also for different scenarios, not this particular scenario as such, but we are making things happen. How it is possible? Credit goes to technologies such as IoT, AI, digital twins, and so on. So this is one example. Let me give you some example for our respected seniors who have also joined this platform today. So some of us, we have elderly parents at home, right? And many times, even if our heart and mind stays with our elderly parents, sometimes we have to physically stay away from them, right? And even if we are staying away, but we are concerned about the health and welfare of our parents. And in old age, as we all know, that one of the common things that happens is mobility impairment. And the other thing is that sometimes there are, old age related falls, so somebody, the old age person often falls down, right? So it happens, falls can happen to anyone, but, it is often seen that it is common among the elderly, right? So you see, the first thing that, so with age, mobility impairments come. So wouldn't it be nice that as an elderly person, I'm sitting in my sofa, I need to drink a glass of hot milk, and everything is going to be done through the press of a button, and the hot milk is going to be taken out, sorry, the cold milk is going to be taken out from the refrigerator, put in the microwave oven, heated up, and be delivered to me near my sofa where I am sitting. Or if I am falling down, my children who may be living in another city, or in another part of the world, or my doctors or any other caregivers are going to be automatically informed. So let me tell you, the good news is that these things are happening. So there are technologies that are taking effect: ambient intelligence, smart home automation. Many things are basically happening, because of which things like the scenarios like this are going to be realized very soon. So we are living kind of in a magical world. Everything is going to be connected. Intelligence is going to come. Why intelligence? Because ultimately we are talking about autonomous systems. Autonomous systems should be able to learn on their own. They should be able to understand on their own, right? So connectivity irrespective of where we are, at our homes, at our offices, on the road, while we are driving, everything and anything and everything that we can think of are going to be connected, and the data that we get would help us to come up with these sort of intelligence that would help us to transform our societies. So I was talking about one of the core technologies, which is called IoT, and IoT has been a technology that has been an area of research for me since about a decade and a half now, right? So IoT is where the fun begins. We are talking about things. IoT stands for Internet of Things, right? So things means physical objects. So basically, in the same way as we have the internet, which the capital I internet that we all use to get connected with each other, our computers, etc., around the world. So here we are talking about how we can extend that connectivity to physical objects. So for instance, the chair on which I am sitting at present, or the one on which you are sitting at present, or the projection system of a seminar room, or the air conditioning system, or the lighting system of the rooms, anything and everything are going to be connected, right? So everyday objects or things are going to be internet networked, and all things basically will have not only the processing capability, but also some kind of capability for communication. How it is going to happen? Through another technology, an enabling technology called embedded systems. So there are sensors, there are actuators, there are communication modules, there are geographical positioning systems which can make all of these things happen, right? If geographical positioning systems are not there, there are different other indirect ways of localizing different objects, because localization is a very important thing, right? We need to know the coordinates of the different objects. We need to know the coordinates of the targets which we want to track, which we want to sense, and so on, right? So for indoor, there are different mechanisms. For outdoor, there are different other mechanisms. But putting everything in place together, sensors, actuators, communication, geographic positioning, everything together will help us to get something called ubiquitous connectivity. So in an ubiquitously connected world, anything and everything in the world is going to be connected. So anywhere, irrespective of where you are going to be connected. So looking back, it's just a little anecdotal. I still remember when, so way back when I was living in Canada. So I wondered, so those days I was not much aware of, sensors, and to forget about sensor networks, IoT, etc. I was traveling to another country. I remember that I entered the airport and the door of the airport automatically opened. I was puzzled how it happened. I kept wondering and I did not have any idea about what is a sensor way back then. So sensors have been around. Nowadays we are talking about connectivity and so on and so forth, but sensors have been there for decades now. 1950s, 60s, and so on and so forth. Sensors have been around. So building the sensors, fabricating sensors is a different ball game altogether. And let me tell you that commercially there are different off-the-shelf sensors that are available. Sensors for monitoring how much is the carbon dioxide in the air. Sensors for monitoring whether there is a fire that has taken place. Sensors for doing n number of different things. Whether an object is vibrating or not, getting vibration signatures, and different things, right? So there are so many off-the-shelf sensors that are available commercially, and let me tell you that these are very cheap. These are not too expensive, right? At least the amateur ones. Commercial industry grade ones are a little expensive, but most of the other ones that are often used, right, by students and so on. So these are very cheap. They have very limited capability, but they work, right? So but building one such sensor, let me tell you, has taken a lot of multi-year effort by the inventor of that sensor, right? It's not easy, let me tell you. So just to give you an example, I myself, I am part of a team, a multi-interdisciplinary team at IIT Kharagpur, working on a project named N-Netra. So N-Netra already completed one phase, right? And we have now stepped into the second phase. So even after 5 years basically of N-Netra research, we are still talking about how to build sensors for monitoring pollution, right? Pollution monitoring. So I collaborate with colleagues from material science department in IIT Kharagpur, with colleagues from electronics department, with colleagues from physics department, and so on. So their expertise is basically to how to build sensors per se. And I have a complementary expertise. I do not build sensors. I do not have any idea about how to build sensors. So I take the sensors that they build and then take it beyond. What all things can be done beyond. So that is where my role starts in those projects. So I hope that I could give you some idea about the complexity that is involved when we are talking of these projects, starting from building sensors to connectivity. So we have only talked about connectivity, but let us now try to appreciate this connectivity and beyond little further. So think about the world where anything and everything, the chairs, the tables, the lighting system, the air conditioners, anything and everything that you can think of are all connected. So if you can, even if you do not know, you might be able to appreciate the fact that the giant internet, basically internet works billions and trillions of computers and different other computing and networking devices like routers and switches and so on around the world. So so computer scientists who have joined over here, you can think of how you can abstract this giant internet work as a graph. So if you try to have a graph abstraction of this complex network, it becomes something called a complex graph. So computer scientists, you know what is a complex graph, and you know what is the properties, and how it is difficult to model such graphs. So the existing the bookish graph theoretic methods that we are familiar with, these cannot be used to model these complex graphs, right? So there are a lot of characteristics and features that basically prohibit us or make our life difficult to have a graph abstraction of it. So those who work from a computer science point of view, often on IoT and such, often some of them are interested into the graph theoretic characterization of these networks, right? So it's a complex graph. So that's a research area by itself, right? Again, I mean, it's so complex that only a few who are focusing on the theoretical aspects of IoT, they focus on that. But so others like me, we try to build strong and well performing networks that are going to be the backbone in the communication process. We talk about what will be the architecture, the network architecture, how the throughput can be guaranteed, how the delay can be minimized and guaranteed, because many of these IoT applications require real-time guarantees, right? Because even seconds delay may not be tolerable. Somebody getting a heart attack, right? Even seconds delay is not tolerable, right? If there is an IoT application talking about fire spread monitoring, right? Seconds delay is also not tolerable. So you can understand the guarantees that are required in the for catering to these kind of application areas. So my team basically focuses on these sort of aspects. We also build applications, we also build products, but so our focus from a research point of view is more on the networking aspects. And we also talk about how we can use that data that we are generating and storing in a distributed fashion, because as it turns out that most of these large scale IoT deployments will exhibit a distributed, decentralized data data storage system, right? So basically, we are talking about a very complex database, let us call it, which is decentralized and distributed. So how do you run inferencing in such cases? There are so many, n number of problems over there. So we are talking about. Unless you want to speak, may I request all of you to kindly be on mute, right? Thank you. So we are talking about having real-time guarantees in terms of decision making also. So for that, how you are going to run your intelligence at the edge, on the fog device, at the cloud, and then how are you going to synchronize the inferencing among the different edge devices, right? So all of these complexities are there, and my particular focus area is on these particular aspects. So having understood the background, let us now talk about connectedness a little bit further. So we are talking about large number of smart applications, attractive applications. As we know, the current government in the federal level, it has been pushing since the last 10-15 years, it has been pushing building smart environments, smart cities. It all started with identifying 100 smart city projects, right? Bhubaneswar itself is a smart city, right? Kolkata, parts of it is part of that smart city project, right? So like this, many of the projects, greenfield, brownfield, so it's a complex thing, right? So many smart cities have been built in a phase-wise manner, and many are still being built, right? So these are building smart cities is a very complex thing, let me tell you. I'm not sure how many of you have actually gone into data centers and control rooms, etc., of the smart cities, but let me tell you that it's worth visiting, right? If you have not done it, pay a visit to the nearest smart city data center, right? You will be able to appreciate, the level of complexity that is there, right? So like this, there are all sorts of smartness, smart buildings, smart homes, smart hospitals, everything, smart agriculture, you just name it, everything has, everywhere, everybody is trying to make things smarter, right? Smart transportation, mining, all sectors. And another one is industries. People, including myself, we have been talking about industry 4.0. We have been now talking about, industry 5.0 and so on. So I myself, I am part of an IIT Kharagpur, grant initiative where, along with several of my multidisciplinary colleagues coming from manufacturing and mechanical background, we have built, the Center of Excellence for Advanced Manufacturing, where we are executing different projects involving IoT and different other domains, basically, right? So we'll not talk about it now. So, but, let us come back a little bit, let us sit back and try to understand at a high level, what sort of complexity is there. We are talking about, at a high level, three primary layers. One is the layer with interconnection of different sensors at the ground level, at the physical level, as we call. That's termed as the perception layer. At the little higher level, we are talking about how the different sensors are going to collect the data, which can basically be taken to a device which is called the edge device for, for doing something, right? Either for onward transmission or sometimes for local processing. So they serve as local gateways, right? And there could be, mega storages, mega processors in the cloud, somewhere where we also do not know where those cloud servers are located, and so on and so forth. We have Google Cloud, Amazon Cloud, Oracle Cloud, including IIT Kharagpur also has its own cloud, right? In the building from where I'm talking about, in the ground floor, several years, I mean, probably we were among the first IITs, maybe the first IIT to build our own private cloud. It is called the Meghamala Cloud, right? So Meghamala Cloud, it is still there. We are basically, in my current administrative role, we are trying to improvise it, modernize it, and so on and so forth. But the point is that cloud gives the end users an impression of a mega storage, a mega compute platform, and so on, right? And where the data can be stored and further processing can be done. So this is the three-layer abstraction that I think you would be able to appreciate based on what I just narrated. At the ground level, there are different devices. Many of these devices, in the early years when we were, we started working on IoT sensors, sensor networks, and so on, I used to buy, my team used to build these electronic boards and so on, right? But now, very cheap, off the shelf, very powerful development boards are there. So most of you must have, at least, even if you have not used, you must have heard about ESPs, Arduinos, Raspberries, and so on and so forth. These are commercial, off the shelf, open source hardware platforms, right? Which are very, so these are wonderful things, wonderful innovations that have come, right? Even though we built something ourselves, but that's in the trash, so we are not using it anymore because, we have been outbitten by these modern commercial ones, right? So then comes sensors. Sensors do sensing. So different sensors have been fabricated. The science and technology behind them are very different. A lot of innovations, starting from the materials, sensor characterization, right? Then so a lot of analog front end and so on and so forth. A lot of things are there. So so people who work on these sensors, they basically do that, build that, and we get things like this, the pictures that you see. And another thing that is also very powerful is basically the control. So if you think of IoT, or even better, if you think of the cyber physical systems, what we have are primarily sensing, then processing, communication, right? Then there is another one which is very interesting, which is for the control. So that will basically close the loop, and for that we have the actuators, right? Actuators will help you to perform something, some mechanical action or some action, so based on the inferences that you get from the data that have been collected from the sensors. So we have multi-layered kind of scenario, IoT architectural scenario with sensing, networking, services. IoT is service centric, so we talk about the service composition, service decomposition, integration, many other things are there. Depending on the use cases, basically we need to do a lot of these operations, and the interfacing basically to serve the different applications. So now with this background, I will be little fast because I think the foundations are very clear to you. We'll now talk about some of the glittering things even further. Agriculture has become smart agriculture. Industries have become smart industries, smart factory floors, smart transportation. And let me tell you, my lab, the Swan lab, it has basically footprints in each one of these three domains, right? We have executed several projects on IoT based agriculture. So for the sake of time, I'm not going to elaborate it any further now, but during the discussions we can take them up. But you can also search on my Google Scholar. You would be able to get very good summary of what I have done. And please do not if you are curious about these further, you can also visit my website. The website is a little dated. It has I did not find time to update, but still you will be able to get some fair idea about the kind of works that we do in the industries. Just to give you an example, like so I have executed few projects with the Tatas, including a very recent project for overhead crane monitoring in factory floors, right? In one of the subsidiaries of Tata Steel called TSDPL, right? So it's something that is working. It's in action right now. Also, we are basically from my office, I am able to monitor what all things are happening with the the logistic equipments that we have where we have deployed our systems, transportation, smart transportation, and so on. So when we talk about IoT, it's not just terrestrial, right? We are talking about flying IoT, right? With the help of UAVs. Again, UAVs come in different types, right? Different types of UAVs are there. There are quadcopters, hexacopters, octocopters, fixed wing UAVs, and so on and so forth, right? And there are underwater IoTs also. So underwater means like under the surface of the water in oceanic bodies and so on, where you can have these things connected, right? So there are good reasons why you want this connectivity, like the use cases that I initially told about. For each of these different domains, there are so many good things that you can do. One of the very important aspects of flying IoTs is something called swarms of UAV. So swarms means network of UAVs which can talk to each other, like in the picture. So those of you who have who were in the earlier years, who were in IIT Kharagpur, so this is basically the experimentation we have been doing in the Tata Steel ground, right? So this is our Tata Steel sports complex. So where you can see, this is one type of network that we have, right? And this is another type of network. Each of them, they have their different network terminologies, but I am not talking I'm not using the jargons here. So so we were among the first, not right now, several years back, much before COVID, we were among the first to demonstrate in the country flying UAV swarms, right? And now, we have taken our efforts in UAVs to a completely different level with the help of current advancements of AI technologies, right? So anyways, so those are these are pretty interesting, and they can be used for agriculture, they can be used for several different purposes, right? So these are some of these. Again, this is from this is an IoT deployment for UAV based imagery for aerial crop health monitoring, and this is again from our experimental farm in IIT Kharagpur, agricultural experimental farm in IIT Kharagpur, as you can see. So this is a grid-like pattern, so this was basically so the whole idea is that can you fly not one, but a swarm of UAVs to quickly in real time monitor the monitor different things based on UAV based imagery, right? Monitor, for example, whether the crops are water stressed or not, whether the crops are nutrient stressed or not, and like this, basically different other interesting problems from agriculture can be addressed with the help of these sort of systems. On the left hand side, this is one of the sensors that we had built, although sensor, as I said earlier, I do not really build sensors, but they just, this was one of our based water level sensor that we had built in house, although our expertise is not in that, but this is something that was well calibrated and it worked. And again, these are some of these pictures that you can see in our experimental farm in IIT Kharagpur. The IoT nodes deployed, interconnected, it's a master slave kind of architecture, clustered architecture that we had used. And this is basically a deployment that we had done about 20 kilometers from IIT Kharagpur campus is a place called Benapur. So there we had deployed, although this installation is no longer there. I mean, installation is there, but it's kind of phased out now because the project has ended and we have not done anything beyond. But I just wanted to show you that what all possibilities exist in this direction. So that's agriculture. In the power sector also, a lot of things, so that's basically from one of our projects with CESC Kolkata, right? CESC is a electrical power distribution company based out of Kolkata, and we basically executed some projects over there for some of these IoT based monitoring of different different installations in some of their substations. Basically, there are a lot of problems that are there. Even when you are trying to deploy your IoT solutions, there are a lot of issues that come up, let me tell you, due to the electrical fields that are there and so on. You get plenty of noise, so how do you cancel those noise? And many other issues are there. It's not it's let me tell you that it's non-trivial, right? And similarly, we also executed another one, how UAVs can be used for monitoring of high tension lines, right? So so distribution networks, electrical distribution networks, how you can use UAVs for their monitoring and so on. In healthcare also, likewise, many things can be done. This is one of the projects so that I had executed long back with the funding from IIT Kharagpur only. It was long back. There was one of the incidents, several years back, where one of our students, basically, while he was being taken from in one of our ambulances from our IIT hospital to another city hospital. The condition of the student deteriorated, and eventually something, something that was undesirable, it happened, right? So that basically inspired me at those days, that how can I use my expertise to build something where the things can be a little bit better than what it is. So basically, I collaborated with some doctors from AIIMS Bhubaneswar, with our BC Rai Technology Hospital doctors and so on, and we came up with something called AmbuSense. So those days, AmbuSense was in the news. Now if you search, so it was a patented system, and if you search, you would be able to see how, in a privacy aware manner, because we are dealing with patients, right? Privacy awareness privacy protected systems are very important. So with complex computational algorithms, implementation of those, basically we try to privacy protect the data. And how we can do that to have patients who are being ferried in ambulances from primary and secondary healthcare centers to typically the apex hospitals in big cities, or tertiary care hospitals in big cities, how they can be end-to-end monitored, right? So we built this AmbuSense system, which eventually evolved into a product which is called AP1. And through my startup, we are trying to, we are commercializing this product. So it has, the name has changed now. So it's the commercial interface of that is called AP1. So those of you who are interested, if you visit the company website, it's an IIT Kharagpur startup. If you visit the company website, you will be able to see not only AP1's fact sheet, data sheet, but also different other products, right? So we have done a lot of trials in different routes, including in Bhubaneswar also. So this is AP1 that I was talking about. It has different features. I'm not going to talk about it, but it's at a high level, it's a ubiquitous and portable patient health monitoring device. So this is very interesting because, so it's portable, right? Unlike other, smart ambulances where things are not portable, right? These are built into the ambulances. We are talking about how, so let us say, we are monitoring the patients in the bedsides in their hospital, their condition deteriorates. Basically, so the entire thing, including the device, this AP1, can be put into the ambulance, and so along with the patient, the device is going to reach the destination hospital, and by the time the patient arrives at the destination hospital, the doctors have all the data, so that immediately they can start their interventions. They can start treating the patient instead of waiting for different other tests and diagnosis and so on and so forth, right? So last thing that I would like to emphasize, actually there are quite a few, but I'm seeing, just doing a time check, and I'm finding that probably I need to conclude in another 10-15 minutes. So let me give you a few other things, right? So intelligence is something that is the key word nowadays. Intelligence everywhere. Connectivity and intelligence come hand in hand. So we are talking about intelligence. For intelligence, our friends are EIML, that everyone, I'm pretty sure, including the domestic help that we have at our home, I'm pretty sure that they have also heard about EIML. EIML everywhere now, right? So IoT and EIML, if you put them together, that brings you wonders, right? But the problem is that the requirements of EIML, the conventional well-known EIML techniques, are unusable for IoT, IoT scenarios, IoT installations. You cannot use them as such, right? For different reasons, right? So inherently they are not usable, right? So again, the question comes that how you can have lightweight solutions, quote unquote lightweight solutions, built for IoT systems, right? How you can do that. So that is where low resource ML, right, comes. Resource constrained machine learning. Let me just tell you, low resource or resource constrained machine learning is such a hot area of research now that there are several theses, including one of my students also, right? Few years back, she completed her PhD thesis on this resource constrained machine learning. Her area, I mean, her entire thesis was on resource constrained machine learning. It's a very attractive and highly challenging area, let me tell you. A lot of research is going on. We have also done our bit, right? Published in high or popular venues, but still, we also know that a lot of other things need to be conquered, right? A lot of green elements still remain. So it's a, how do you do that, right? So that is where a lot of, but the beauty is that all these smart factories, smart agriculture, everything, right, requires it. For what? Let me tell you at a high level. Again, ML can help you predict forecasting and predictions. ML can help you to do that. Machine learning can help you to do, to solve classification problems, to solve clustering problems, So if you have a bunch of data, you want to identify, if there are clusters which can give you some idea about, some idea about what might be going around the systems based on the data that is acquired and plotted, right? So there are different algorithms that can help you in clustering, classification, prediction, and so on and so forth. But as I said, that for use in IoT, you need to engineer and re-engineer them, right? And that's non-trivial exercise, right? So predictive analysis, take for example a very simple thing, predictive analysis. So let us say that in a factory floor you have different connected machinery, right? And even before one of these machines basically malfunctions, can we get an idea that this particular machine is likely to fail after 3 days, 4 days, 5 days, 10 days? Can we do that? If we can do that, basically we can avoid the breakdown of that machine. And if we can avoid that, then what will happen is that we can basically, we can breakdowns are, as you can imagine, that in most of the businesses, breakdown of a machinery costs them heavy. So breakdown is something that is not acceptable, right? So can we use prediction mechanisms to identify when a particular machine is going to? So there are different types of analytics. So nowadays you must have heard that people are talking about analytics, not just analysis, analytics. So there we are talking about what? We are talking about operational analytics. In real time you want to know what else things are going on, right? So operational analytics, predictive analytics, prescriptive, not just predictions, but you also want to prescribe, right? Going beyond, right? Prescriptive. So like that, a lot of things are there. So, and you must have also heard about the evolution in AI in terms of, people are talking about explainable AI, safe AI, reliable AI, generative AI. So this chat GPT that we all are very much familiar with nowadays, it's a product of work in the direction of something called generative AI, right? So how generative AI solutions are, chat GPT is, how much useful it is, right? So just to give you an example of this generative AI, because we have been talking about it, one of my interns, summer interns, you see many of these summer interns coming from some of these tier 2, tier 3 institutions of our country, educational institutions of the country, so they are great assets. So what they did, one of the students, I gave him a 2-month job. So he came and he built a generative AI based solution towards smart campus. So we already have an enterprise level, right? Enterprise level, enterprise level system in place in IIT Kharagpur, for example, where a lot of data basically is acquired and stored, right? Data coming from different departments, different infrastructure, air conditioners, electrical maintenance, and so on, right? Dispensaries, quarters means the staff quarters, etc., faculty and staff, markets and other businesses, and so on and so forth. So you get a lot of data, right? So what can you do with the data? So this student was given this task to build a generative AI enabled smart campus query management system. So it's kind of, you can think of that you have all the data from an institution in place, and then different actors like students, faculty, doctors, administrators, they can use the natural languages in the same manner that you use in ChatGPT or similar AI tools. You type in your own natural language and you get good, meaningful, summarized reports. And that is what we need. We will get in a very summarized and modular fashion these reports, and these are going to come. So it's a simple implementation, but I just wanted to appreciate two things over here: how generative AI can be used to do a lot of things based on the data that are coming from different sources, including IoT devices, right? And the other thing that I wanted to appreciate, if there are students who have joined, so many of the students, so we have to get out of the mindset that all the students in the IITs are the only ones who are creamy. It's not like that. Let me tell you, based on my experience, there are many non-IIT, non-IISc, non-ISI students who have done wonders, right? And I myself, my lab is a live example of, and I can give you like hundreds and hundreds of stories of students who have done wonderful work, so over here in our lab, right? So students from all these different tiers of institutions are invaluable resources. So, in the interest of time, I'm not going over the flowchart overall, how generative AI and LLM solutions can help towards this kind of goal. But let me just tell you that intelligence have to be integrated, with the existing IoT frameworks. So AI ML becomes the core. And then you have all of these different things like query management systems, sensor data analysis, automated actuation, automated control, real-time threat prediction, and so on and so forth. So this part, I'm going to go over a little fast because, I wanted to come to something very interesting. So in the education domain also, a lot of things are happening. Smart glasses, virtual reality-based learning, IoT wristbands for tracking student engagement in the classroom, whether the students are stressed or not, whether they are focused or not, building holographic teachers, AI-generated teachers, basically, who will be available at any time, right? Holographic teachers, real-time adaptation. Let me tell you, these are, they might appear to be sci-fi at this moment, but these are all different projects. I'm not talking about something out of the blue. So these are things that are being executed in different parts of the world as different projects. Give another 10 years, you will see them in practice in the different institutions. We are already actually, as part of our recent administrative the transformations that we are trying to have in IIT Kharagpur, one of the things is that we are building smart laboratories, smart infrastructure, smart classrooms, and many things are becoming smart. So some of these that I'm mentioning over here are actually, they are basically being implemented. These are not fully hypothetical. Including, let me tell you that at present, so you must have heard that in recent times in different educational institutions there have been suicides, right? So so my team, we have already built and we have filed IP protections on that how we can protect these students or from having eventful kind of these kind of events, right? Suicides and so on and so forth. So AI tools we have built which will collect passive data, and based on that the vulnerable students will be identified and the authorities are going to be informed so that an important life can be basically saved, right? So we are doing it. I mean, it's already done by our group. We have 2 systems that we have built. Anybody who is interested, just get in touch with me. We are piloting at the present, but it will be soon deployed hopefully in our campus. We are already in talks with our highest level administration. So so business, basically the IoT business basically is booming. It's exponentially it is growing in almost any sector you can think of, whether it is consumer IoT, industrial IoT, commercial, infrastructural IoT, everywhere you will see a big boom of IoT and its and its applications. So people are talking about digital twins. We built one of the first, for our lab is well known for something called sensor cloud, right? So I'm not talking about it any further now, but those of you who are interested, just search for digital twins and sensor cloud with my name. You'll be able to. So 2 references are given over here itself. So we have built some of these systems, right? And some of them are very unique. And for example, the sensor cloud based systems that we are talking about, where sensors are going to be delivered as service for businesses, right? As utilities, sensors will be available as utilities, right? So those sort of things, we have done, and very unique in the world. One of the first technologies that we have built, and for which we are very much proud. It's called Sensor Cloud and Green Sensor Cloud, because we are talking about carbon footprints, how we can minimize carbon footprints and so on. So we'll talk about, we'll skip that for now. So IoT in smart factories, whether it is for welding processes, manufacturing, other manufacturing processes, IoT finds its place. And this is the left-hand side figure that you see is from one of our papers, right? Research papers, where we have a complete end-to-end solution for real-time monitoring and feedback, of a type of welding called friction stir welding, along with one of my colleagues, very prominent in this domain, Professor S.K. Pal of Mechanical Engineering Department. We have been working in this domain, and we have built systems and have also patented them, right? So the last thing that I would like to, not last, but one thing that I would like to mention is so IoT should come as a tool for the transformation of our underprivileged sections of the society, Indian society, right? And towards that, with generous support of the government of India, we executed one of the projects which is called the Tribe Connect project. Those of you who are interested, you can do a Google search, you would be able to get more information about it, where we built some 11 or 12 different TRL level prototypes, including, in the tribal communities, how you can have affordable, affordable on the spot screening of anemia. So in tribal communities, it is often seen due to malnutrition and many different other reasons, basically. So there is, one is anemia, second is tuberculosis, right? So we have built systems, affordable wearable systems, right, which can be used to quickly identify these diseases, and we are expanding it to different other diseases also. And we have done that, we have shown it, and even one of these the technology has been transferred to one of the organizations. So that's it, and I would just quickly go to the last slide very quickly, because we have already run out of time. I will come to the last thing, that is something that I wanted to talk about. That's the future. So where are we? What we want, where we want to be in the future. So we are talking about an ecosystem in the future, let us say after 10 years from now, right, where we are going to have AI powered IoT, which is going to be self-sustaining, which is going to be minimally or ideally completely autonomous with no human intervention. So at present also we are building in patches, but at that time, let us say give another 10 to 15 years, we all will be able to witness such kind of systems in our workplaces, at homes, and so on. Second thing, the way the low cost brain computer interface systems are BCI systems are evolving, we are talking about not only monitoring, collecting the brain signals from different different individuals to understand what they are thinking, what is their, whether they have any mental diseases and so on and so forth, but also we are talking about brain to brain connectivity. So I'm just jumping ahead, but let me tell you that that is already in the works in my lab, right? We have built it. Very soon, the patent is also going to be, the IP is going to be protected very soon. So just, I shared with you, I have not disclosed how we are doing it, but I'm telling you the target that we have achieved, and we are trying to strengthen further. Another very interesting and important domain that is particularly important in India is the energy sector, right? So smart, sustainable cities, right? Sustainability is very important, not just smartness. So energy saving, how we can do that, and so on, right? Coupled with that, the final point that I would like to make is we are talking about in IoT ecosystems handling a lot of data. And this data will have to be handled with care, because data are coming from our homes, data are coming from different businesses. And if this data is not handled with care, even if you come up with all these attractive technologies, everybody is going to be reluctant to use these technologies, because I do not want, for instance, the data from my bedroom to be known to a hacker who will get access to the data and will be able to know about what is going on in my bedroom. That I do not want. I do not want as a business that my competitor would be able to hack into the system which is having and become and become competitive with us, right? And be a serious competitor. We do not want that, right? So how you handle that data is very crucial. So ethical, privacy preserving handling of the data is very crucial, right? And all of these will have to be done in a very responsible manner. So with this, I come to an end of this talk. I would like to thank all of you for being patient. I have overrun the time that was allotted to me a little bit, and I thank you all for remaining patient with me during this additional duration of time. Thank you. Over to you, sir, Professor Acharya.
And thank you very much, Professor Sudeep Misra, for your beautiful talk. And definitely, it has given a lot of insight to many people like me who are not really acquainted with these present-day technologies. Okay. Now, it was really interesting, and I hope everybody would have liked it. Now, I request that some questions could be really raised by the persons actually who are present, or you can even put your question in your chat box. So, Professor P.K. Misra, would you like to start?
Sir, you are on mute.
I think you are mute. Okay, okay. Now, anybody else? I find many new names here. Dr. Abhishek Saxena. Would you like to?
Not connected.
Anyway.
Not able to speak. Not able to speak. Not connected.
Yes, please. So nice.
No, I don't think you can hear me because it doesn't. Mic disconnected, I think.
Sir, you are audible. You are audible.
You're audible. Okay.
Yeah.
Yes, absolutely audible and visible. Please.
All right.
Yeah, both.
I am Lieutenant General Sundaram I was in the missile program. Now I'm interested in disaster management, how to help people. And one of the things I'm looking for connection and intelligence everywhere is maybe how to use even rats, because they can go under any building as a lot of things are people are buried, trapped under debris, but we can send rats there. So the intelligence of rats to be combined with all the other IoTs we are thinking of, I'm sure it can be done. It is being done in certain places. I request help of all of you, some of the students, if you can think about it, you can get in touch with Professor Sudeep, and then through that, I am from Bangalore and stay outside in Bangalore in a village area. I am now 90, but I think I can still deliver something before before I go even higher, because I'm convinced it can be done. And Ukraine is happening, Gaza is happening. When you have earthquakes, will happen, flooding will happen. You can definitely do it. And what you are doing, even Kharagpur, you can think of your people who can look off a rat cyborg. I must tell you that particular thing has been even blessed by Modi Saab. In the Indian Science Congress of 2020, he said the DRDO and others should get together and see how it can be done. And a limited amount has been done using a chip in the brain. It can be controlled left, right, and all. But I'm saying, why damage a brain? We can do it by training. Like it is being done. It's being done in Tanzania. It is being done in China. It is being done in UK. India can also do it. That is my only message to this place. I'm sure before I leave this world, it will happen. That's what I'm looking for. I'm trying to work with NIMHANS, National Institute of Mental Health and Sciences, because they work on rats. There is one Professor B.S. Shankar Narayan in behavior analysis who has said he will help in this particular area. It will become both AI and AOT. AI can stand for artificial intelligence. It can also stand for animal intelligence. Let us combine the two AIs and do service to the humanity. Please think of it, all of you who are listening in the various IITs, and you can get in maybe touch with me. My email is VJS. I'm Vijay Sundaram, VJS307@gmail.com. If any of you get into this email, or I'll get in touch with. I'm also a member of the National Academy of Engineering, though I'm an old army fellow, but now having served in border areas and seen landslides and these things, I think we can do it. And that was when I was very young. Now, 90 plus, God has been kind. I think I want to deliver this before I leave this world. Thank you very much.
Sir, absolutely, absolutely. Thank you so much, sir. It's a you come with a lot of rich experience, and
Yes.
in a short time, whatever you have shared, not only with me but also particularly the younger participants over here, that's something that is worth taking, worth exploring. And you have already summarized, but let me just elaborate a little bit for the convenience of others who may not be familiar. So two or three things I would just like to mention. So disaster management, basically, so there are in India, basically there are different authorities like NDMA and so the NDMA is one of them. Like that, basically state level disaster response mechanisms are also there. So this is basically a message for those who may not be aware, right? So for them. So again, disasters are also of different types, natural disasters due to floods, earthquakes, etc. This is one type. And man-made, human terrorist intervened disasters, right? Like the ones that we have been recently experiencing and hearing in the news and so on. So different types of disasters require different types of interventions. But what Dr. Sundaram, what he mentioned, so from his experience, is something that is worth pursuing. It is already happening. I had seen for use of cockroaches for the purpose. Similarly, other rodents like rats and mice and others can also be used. So essentially, small chip is fitted to the the head portion, and so certain things happen and so on. So wherever these these insects and these animals, wherever they travel, so you can basically find out what is the condition, etc., including, sir, theft of. So enemy countries are sending rats and cockroaches so to the neighboring countries and getting the data from the other side. That is also happening. So these all these things are possibilities. Lot of research is happening, and I have already taken your email address. I would like to connect with you offline on this, and your rich experience, if we can leverage and if we can do something. And we should not, sir, you mentioned few times certain things which I found to be negative. So I would not consider in that spirit, right? So I'm pretty sure that your experience will help us in several years to come, and we will all get blessed through your rich experience.
I will definitely get in touch with you, Professor. I
Sure,
must
sure.
also tell you, but my classmate in intermediate was there in the first batch who come out of IIT Kharagpur. He joined in
Okay, wonderful,
1951.
wonderful.
First batch he was there. Of
Right,
course, I
right,
went
right.
BSc and the army, that's different. I'm getting back to you. Thank you. You'll hear
Thank you
from
so much,
me,
sir.
right?
Thank
If not
thank you,
tonight,
thank
tomorrow
you.
you'll definitely hear from me. Thank you.
Sure, sir. Sure.
And anybody else. Thank you.
Thank you, thank you.
Anybody else would like to ask some questions?
I see a few in the chat box. I have not read yet.
No, some chat box actually few good things are there.
So first is that, sir, will I get a certificate for participating? Somebody is asking, sir, Professor Acharya, you can, I do not know, you can respond to this one. Certificate for participation certificate.
No, actually, we do not have any such things. We'll think of actually, because so far actually we do not have this any provision of that type, and I have to take actually this from Indian National Academy of Engineering that whether actually could really issue such things. Okay.
Right, right. So IEEE, we also host two, lecture series, global lecture series. And initially, we also did not have this provision, but we worked out with IEEE, and we are now giving certificates, right? So that INA may also, but I mean, for that you need to get some, some clerical support from INA for that, right? So somebody has to do it. Right, so all the
No,
participants who are
that is one particular thing. The second thing is actually certificate should be really given if there is actually some sort of, examination or evaluation is actually involved. If there is actually no such thing, then the certificate has got no meaning.
participation, sir. Participation certificate. I think
Just
people are asking.
participation, that's all.
Yeah.
Okay.
Okay. So can we go to the next question?
We'll
So
definitely explore this possibility.
Sure. Next question is that what kind of IoT and AI projects that we could take at school level to prepare future students? Wonderful. So this is asked by Mr. Or Dr. Anuj Kumar. So let me tell you that Ministry of Electronics and Information Technology since last several years have been running a mission called Atal mission. And my son, he himself studied in a CBSE school over here. So 6 years back, now he doesn't spend time for doing all of these things. He's in class 12. But when he was in class 6, at that time, he got initiated into this one of these Atal tinkering labs, right? Atal tinkering labs. And let me tell you that many of the schools are doing it very seriously, including the on-campus schools that we have in IIT Kharagpur. And my son, he himself has built some very nice, IoT-based projects where, age intelligence in a very rudimentary scale, of course, but, so they are all doing it, for waste management, for, and many other like social causes, etc. So these are actually happening. So in case you do not already know, Atal tinkering mission, Atal tinkering labs, right? Basically, you search, you will be able to get some idea. Next one is, yeah. Any question?
Yes, sir. Sir, actually, I'm teaching in Kendriya Vidyalaya, IIT Kharagpur only, sir. And
Anuj ji, right.
Sir,
Very nice to see you.
Thank you, sir. Sir, actually, recently we had just concluded two activities, Buildathon and Hackathon, which is pan India activity. And actually, I really wanted to share ideas or things that can be of futuristic, because whatever presently students are doing, they are just copying something from YouTube, and they are just every year we are getting same kind of projects. So this year we have prepared two projects, and one is Jal Trinetra, where my students are working, so that they are controlling the availability and temperature of water, and also using computer vision to provide the security alerts to the school management. So I just wanted to know if few projects like these can be suggested so that I can take them at my school level, and really it will boost the morale and level of our students, sir.
Yeah, right. So there are plenty actually. Let me tell you, plenty. But the thing is that so which one involves? See, research is a completely different. So research has a trajectory, right? So whenever we are talking about, so there are a lot of philosophical questions that would have to be fundamentally answered first, right? So at the school level, what we want is kids should learn the ABCs, right, of all of these things, right? So do we really want to burden them with research and innovation, patenting papers and so on and so forth, right? So that's a philosophical question. So even if we want to do, there are so many different ways that it can be done. So we can catch up because you are in Kharagpur, so so we can catch up.
Sir, I will get in touch with you.
Yeah. So, but
Professor
very nice
Mishra,
to know what you- yeah.
I've sent you an email. It has gone through. I will get
Okay.
in touch with you, Mayor, with a little more, few
Sure,
more
sure.
details. Email is already
Thank
with
you,
you.
thank
My email is
Thank-
with you.
I will check that and I will respond.
Okay.
Thank you so much, sir. Thank you. So
Any other-
yeah. So I see a few other questions also. Very quickly, Pratham Majumdar, wonderful and insightful presentation. It will be great if you can share some idea about how can sustainable and energy efficient wearable sensor systems be designed for continuous patient monitoring while minimizing communication energy, ensuring. So that's basically, just have a look at AmbuSense and this thing. You will get some idea. If you want, you will get some idea. But a lot of works we are doing actually. Let me tell you, very recently we have filed a patent for some wearable based lung condition monitoring and identification of lung diseases, right? It has been done in collaboration with some medical practitioners. So like that, actually lot of things are there, right? So for continuous patient monitoring, so a lot of things are in works, and I'm sure that these will mature in another 10 years. You will find them in the market in usable conditions, right? So that's there. Very quickly, J. Uma Mahesh, as mentioned, disaster management in real time can add any chip which can vibrate when rat or enters into the car engine. Car engines are getting car engines or car, a lot of different parts are getting damaged also due to these rodents. Even the car engine is offline. My friend spent nearly how much 50,000 rupees because of the rat mess. Yeah. I also spent very recently 2 months back. Rats basically damaged lot of the car parts for me, right? So about 20,000 rupees I had spent. I am working in the area of LoRaWAN from NIT Rourkela. Yeah, very nice to know, J. Uma Mahesh ji. Yeah, so thank you for sharing your experience and thoughts. So definitely, lot of possibilities exist actually in this domain. So yeah. Oh, so Yudhishthir sir student. Very nice. So Yudhishthir was my PhD student in NIT Rourkela. He is there as a faculty in computer science department. So my grand student, right? So
Yes, sir.
yeah. Thank you.
Thank you, sir.
I got a MEMS gyro from Professor Lahiri, tuning fork gyro. He made it for us from IIT Kharagpur.
Right.
Long
Thank
ago,
you.
long ago. We have used
Right.
it.
Right. Any other question from anyone?
Any other question from anybody? So if there is no other question, I request Professor Renu Sharma to propose a vote of thanks.
Thank you, sir. Good evening to all. On behalf of INA Bhubaneswar chapter, jointly with Shiksha Anusandhan deemed to be University, CSIR IIT Bhubaneswar, IIT Bhubaneswar, NISER Bhubaneswar, ICT IUC Bhubaneswar campus, and IEEE Bhubaneswar section, it is my privilege and honor to propose the vote of thanks for today's enlightening session. First and foremost, I express our deepest gratitude to our esteemed speaker, Professor Sudeep Mishra, and a Chair Professor, Department of Computer Science Engineering, IIT Kharagpur, for delivering a remarkable lecture on all things connected, the age of intelligent networks. Sir, your insight on intelligent system, future network environment, development and evolving landscape of connectivity have truly broadened our understanding and inspired new directions in research and innovation. We are grateful for your time, your effort, and in depth of knowledge you shared today with not only with us, with our students too. I also extend my heartfelt thanks to distinguished leadership of all the collaborating institutes with INA Bhubaneswar chapter for their continued support and guidance in sustaining this prestigious lecture series. My sincere appreciation goes to all the faculty members, research scholars, students, professionals who joined today and enriched the session with their active participation. Once again, I thank you all for making the 17th distinguished lecture in a meaningful and a memorable one. Looking forward for your presence in upcoming lectures of this continuing academic journey. I once again thank the speaker of today's distinguished lecture. Thank you, sir. Thank you so much for enriching us with such a wonderful topic. Thank you. Jai Hind.
Thank you so much, ma'am. Yeah, so thanks to all of you. Thank you, ma'am, and thanks to Professor Acharya, a father-like figure for me. And Professor P.K. Mishra, I am seeing him after a long time virtually. I wish to see you in person. Then Dr. Sundaram, very nice to talk to you. Hopefully, we'll be connected now.
Thank you so much.
With trying to come up with certain solutions and so on and so forth. And to all of the others who I have not named in the interest of time, whoever are present over here. So thanks to all of you. And now we all are also connected, right? So everybody is now connected, right? Thank you so much.
Sudeep, one request. So your lecture is recorded. Can we really circulate it? I don't think there is any.
No, it's perfectly fine. It's fine. You can put it on YouTube if you want.
That's what actually we'll do.
Right, sir.
Okay.
No problem.
Okay.
Thank you.
Thank you very much.
So much. Thank you,
We'd
everyone.
like to have you physically sometime.
Sure, sir. It will be an honor for me.
Thank you.
Thank you. Bye.
Thank you, Professor. Thank you very much.
Thank you, all of you.